Hi team. So today the question which I have practiced is question number 219, contain duplicate, is kind of a second part of it. So the question is, given an integer array nums and an integer k, return true if there are two distinct indexes I and j in the array such that nums of I equals to nums of j and absolute of I minus j is less than equals to k. Okay, so what does it mean? So let's say the nums is given as 1, 2, 3, 1 and in indexes would be 0, 1, 2, 3. Okay, so when it should return true, if there are two distinct indexes I and j in the array such that both are equal, nums on those I and j are equal. So here I at index, so this is I 0, this is j index 3. So nums of I 1, nums of j is also 1. So this condition is true, nums of I equals to nums of j, right? And absolute of I minus j, so this I minus j 0 minus 3, absolute of this, right? So which is that 3 should be less than equals to the k. So the k is one more input provided. So k is given as 3. So it's 3 less than equals to 3. Yes, it should return true. Right? So the question is simple, right? But this example actually helped me to reach to an answer. So what I'm thinking was, let's say if in the interview, if only this example was given, so we have to identify this example, otherwise we could mislead to a solution. So now let's see that here. What I was thinking is, see 1011. Like why this example is important here. 0, 1, 2, 3. What k is given is 1. K is given as 1. So here, do we have any? So this is one index I. This is one index j. Nums of I is 1. Nums of j is also 1. So first condition becomes true. Then second condition we have to see this one. So absolute of I 0 minus 2, absolute of is which is 2 less than equals to k which is 1. No, this is false. But here if you see that it's not yet finished, we have to see this combo also, right? So this combo here, now this become I, this become j, right? And now here if you see that I minus j, so 2 minus 3, absolute of this would be 1, 1 less than equals to your k is 1. So now this should return true. Okay, so one simple example is big O of n square, where you will take I and run for all j and see if any of the condition matches this, right? So let's say you have taken is as I and then j with this one, then j with this one, then j with this one, nothing, then this with I, then j with this one, and so you got it, right? It's big O of n square. But as you know that in interview this solution is not accepted. So this, what I did is, using this example I have solved it using a hash map. So let's see that what was that example. 1011 1011, and you also let me know that if you have some better solution for this one, but this is the max. I think it's optimized. So I have created as hash map, right? So this is the hash map which I created, num versus distinct indices map. You can give any other name. Now I am iterating over each nums value. So what I'm doing is I am iterating from here to here. Okay. So currently my I is this. Index is 0. So now initially this map was empty. So this map dot contains nums of I. This map contains 1. No, it would be false. So what I would be adding it into the map, right? So I would be adding this 1 and index would be, I am adding it index here. It index is, so this is index and this is num value. So one index is 0. Okay, so now I move forward, I become this now. So 0. So now 0 num, so this map contains 0. No, it is still not. So what it will do is, it will not go inside this if condition, it will simply add it here. So I will add it 0 and its index is 1. Okay, till now it's very looks good. Now I become move forward, right? So I now this map dot contains nums of I. Nums of I is 1. Does it contains? Yes, it contains. Now what I am doing is, so when it contains, I am evaluating this condition now. Means this has become true now, I and j, because I am iterating from I and goes till the end, right? So whenever the map already contains this, means one index, it has already been found in the previous, right? So consider this, it was found at certain I. Now if at later point, if it is saying that yes, this map already contains this data, this number, means we are finding it again, right? So this condition has become true. Now what I am checking is this condition, right? I am checking this condition. So what I am trying to do here is, the whatever the new in the latest index. So currently the latest index is this 2 minus what is the previous index was 0. So 2 minus 0. That's why I haven't done the absolute, because I am doing kind of this, the higher index minus the lower index. So here what I'm doing is 2 minus 0 is greater than equals to your k. Sorry, not greater than equals to, less than equals to your k. K was here in the 1. No. So k was 1. So 2 less than equals to 1. No. When it become false, what I am doing it? When it become false, what I am doing is, I am updating this map with again nums of I is again 1. So it's again with the 1 only. But index I will put the latest one. So index I will put now instead of 0 to 2. Now you can ask me like, hey Sharon, why you are updating to the latest index? Why? Because see, what we are trying to identify is that the index difference, nums of I minus nums of j, should be less than equals to k, right? So earlier, let's say this was the index was stored, and currently we were getting the map contains for this index 2. So if it is not less than equals to k, then what is the point of storing the previous one? Because now you are going further. Now I will go and increment here. Now if there is one more one head, now its index is increasing. So definitely the k value, like if it is earlier itself it was increasing, than it was not less than k, definitely it would not again be, you will find it would, the value will only increase, right? Earlier it was 2 minus 0, now it will become 3 minus 0. So we have to update with this index, right? So that's why I have updated with the 2. Now I reached here. Now when I reached here, what I'm doing is that nums, this map contains nums of I. 1, yes, it contains, it goes inside. Now checking the comparison. So I'm doing this one. So 3 minus, so earlier I found at 2, 3 minus 2, 1 less than equals to k is also 1. Yes, true. So I'm returning true here, else false if nothing found. So the time complexity is big O of n, because I am iterating everywhere, all the indexes, and the space complexity is also big O of n, right? Because I am maintaining a map. So that is the solution which I found, but I have tried very hard to reduce this space complexity to big O of 1. But I couldn't do it. But if you have some better solution from this, please let me know in the comment section. Okay guys, thank you, bye.